This is Unlocking PyTorch with Prompt Engineering Part 1, 2, and 3. This is Part 1. 2 next week, then after that, 3. There's a concept we're going to talk about, and it's called just-in-time learning, and it has to do with your ability to prompt engineer your own knowledge. And we have never in history had the opportunity to do what we can do now, and I'll be discussing it as we move on. So a little bit about me. I got like 23 cloud certifications, and I am an avid generative AI hacker. I pretty much run a team every week, and it's a lot of fun for me. And my last team, we built a prompt corrector. So fixing a synthetic. It was kind of fun. Like I said, these 3 are coming up. Then in July, we're going to do some CUDA. So I did get the teaching kit from NVIDIA, and I actually posted a video by Matt Berman on a NVIDIA presentation that he basically did a commentary on. And after that, I was so glad that I have the teaching kit. Moving on with that, yeah, generative AI is the new electricity. Companies are beginning to join on, and they're saying more than 50% of Fortune 500 companies have joined. And they're saying they get a 150% increase in work output. And I say if they're getting that, it's not worth it. In fact, that's not what you're expecting from generative AI. And here's an example where Dentons, one of the largest law firms in the world, actually got a 5,000% efficiency from one of their vector database systems. And I've seen efficiencies up to 10,000% with generative AI. And that's not even talking about agents. So an agent's a generative AI, a large language model with tools, the ability to do things. With that, you get even a higher percentage. Well, the previous year, we had what I'd call the big bang of generative AI. That's where suddenly, we went from classification systems to actually token systems that were predictive, kind of predicting what we do next, creating new knowledge. And that was something they would never seen before. And it's so what's called everything to explode. I'm even calling it the AI arms race. If you notice, these companies, these different providers are pouring billions of dollars into these systems, which is pretty amazing. With that said, I'm saying we've been in the area of generative AI. We've had our big bang, but this next year, you're going to see this is the year of devices. And you're going to see all types of devices coming out. And for example, the Copilot PC, which I plan to buy, has a neural net processor, which is amazing. And so I think there was a mention that they were actually having problem. Companies don't want you to process this because it's going up to the cloud and back. But the neural net processor on this machine will process 40 trillion operations per second as an expert in matrix multiplication. And it will run all your AI on your laptop. So it gives you the ability to process PII data on your laptop without it going to the cloud. With that, you have the glasses and you have the phone, and there's a whole host of other devices that people are thinking up and creating that are coming out, which are just fantastic. I want to buy them all. Here's an icebreaker. If you could choose, all right, the area in which generative AI would most change the world in the next 5 years, which would it be? Personalized medicine, hyper-interactive media, AI-powered workplace, or something other? And Sri says number 1. And tell me why. That's great. Medicine, yes. Hey, Grace says medicine. Old Joe says 1. It'd be personalized medicine. Yes, everyone wants medicine. Personalized medicine. Wow, that's high on the agenda there. And so it kind of makes me think about what the difference is between AGI and ASI. So AGI is when computers, artificial general intelligence, can do anything a human can do. But ASI is artificial superintelligence. That's when computers are making Nobel Prize winning discoveries every 2 to 3 days. So when you see quantum computers hook up with generative AI, those type of systems, you're going to really see a boom where technology is just zipping at an amazing pace. Not that it's not now. I mentioned a few posts to put out there, so check them out on LinkedIn. One was this one by Matt Berman on digital human intelligence. NVIDIA, guy in charge of NVIDIA, did an amazing presentation. Additionally, Matt Berman did another one, which is going to be the theme of today's presentation. That's just-in-time code. So if you get a chance, you really want to take a look at that post as well. I'll go ahead and put this in the LinkedIn in the chat. So you guys, if you want to run to that, you can actually get a look at that. But what he's showing is an example. He's showing an example where you're actually actively just whatever you click on becomes a web page. So it's pretty amazing. It's just-in-time coding, but that theme today really influenced me because I'm talking about just-in-time learning as well. Because you don't have to. This has changed everything. I've been in the learning business for a while, and I've developed what I call the story, pull, push method, and that's what we're going to talk about today. You always want to have a story. There's a reason why you're learning, right? And then what we haven't been able to do is pull. Most of learning over the years has been push. We get a bunch of students in the room. We have an instructor comes in, he gives assignment, and he just starts, hammering them with knowledge. Same thing. You join one of these video systems where you learn how to code, and you just listen to people do videos, and then eventually you find a coding system you code. But what a pull is the ability to create your own knowledge, create your own path. And so we're going to talk about, we're actually going to do that today, which should be pretty exciting. Along with the pull, you had the push. There are all those video systems out there. Here's two nice courses on YouTube that I put here. You guys can go to the playlist. One is basically machine learning from scratch. And the other one is a nice PyTorch course for beginners, if you guys have not seen that. So as you create your own learning paths and you build your own learning systems, always want to go back and do stuff like video training, but not until you first have created your own stuff, right? Because what happens is like this: you have a story, you have a reason for doing it. And then when you do a poll, when you start creating your own learning systems, you actually create a whole. You have a place to hang your hat. And then when you watch these videos, then it all makes sense. So it's a pull push system. So today we're going to cover introduction to PyTorch tensors. We're going to do linear regression with PyTorch and logistic regression for binary classification, but everything's going to be built through prompt engineering. And so I wanted to build a course, for example. I want to learn about something. So I want to learn about PyTorch, for example. So I can go into ChatGPT and say, if you were going to make a PyTorch hands-on course, what 10 example programs would you include as an exercise? So let's go ahead and put that in. And this is nice. And so if you can do this for anything, TensorFlow, scikit-learn, pandas, NumPy, whatever you don't want to do it for. So I'll bring up ChatGPT and we'll actually start doing some prompting and you'll get an idea what I'm talking about. And this is 4.0, which is pretty amazing. And I'm just going to paste that in.
Should you tell yourself as a world-class teacher or as a mentor?
Don't have to do it. Don't have to do it because as soon as I say PyTorch hands-on, it's inferred who I am. So let me just talk a little bit about queuing. If I'm sitting here and see these systems are getting smarter. So the stuff we used to tell it, we don't necessarily have to tell it anymore. So if I say join, you might think SQL, right? That's what
yes.
I mean, so it's queued in. So if I said create a PyTorch hands-on PyTorch course, it's already decided who I am just from that. If I'm asking for a hands-on PyTorch class, it thinks, well, I'm pretty much at the beginning level, but they're going to give it to me as an instructor. So all this stuff we used to have to say, we don't have to say anymore because it's queuing it, it's inferring it. So if you look at this, it said basic tensor operations, autograph and backpropagation, linear regression, classification with logistics, feed forward, FFN, CNN, BRNN, GANs, and NLP. So all really good stuff. I mean, if I could learn all this stuff through prompt engineering, that would be fine. Now all I have to do is say provide the code. It's going to give me all the coding operations for all of these systems. Everything you see today has been prompt engineered. I did not write one single line of code for everything you guys are going to see today. So let me go ahead and bring this up and put this link in the chat. This is the companion site that we'll be using today with this system. So I just put the PyTorch course in there. So this is actually, once again, a course that I completely prompt engineer, and I will be completing this. We'll be building this course out as we teach the 3 sessions. So I'll bring it up for you real quick. And what we have in here is an application. So this tells you about the whole course that I prompt engineered. And this is all the topics we'll be treating in this course. Next one is your introduction to tensors. Now, this is very interesting because what you have here, this is not what you think it is. This actually is a simulated code background. So you can actually run code in this. And you can actually change code and put code in here and it'll run it for you. So I never thought in my lifetime that I would build a simulated code system. And you have it right here, and it was all prompt engineered. And you have a bunch of exercises here that you can go through when you're working with tensors. We're actually going to prompt engineer a few other ones and try them out. In addition, we have the simple noise, and that's an MVP. And off of that, I created the linear regression. And you'll see, and we'll run that with your loss on there. And you have all your parameters you can control. You have your logistic regression. And this is the famous student passing a test. How much do I study example? And then we have the PyTorch playground. And this is a playground when you put code in here, I'll run PyTorch. It's just amazing. It's like all this prompt engineered. But let's go ahead and do some stuff. All right. So here's the first prompt we start with. I'll go, okay, let's do some tensor examples. So I'll go, give me a list of PyTorch exercises, a fun list of PyTorch exercises. So let's just put that in there. So I'll go to ChatGPT. And that'll be my first prompt. Give me a list. And once again, you're in charge of your own learning. you went to this and you actually said, what should I learn in order to learn this topic? It gave you a list of 10 things. The first one was tensors. And so you say, hey, give me a list of 10 fun exercises I can do with tensors. Okay, so it gave you a list of 10 fun exercises. The next prompt would be, give me the code. Because now I want to be able to code and play around with it, right? Everyone, here's the first one, create a random temperature. It's going to go through and give you examples of everything in there. So if you went through that and you went through all those exercises, you would know quite a bit about tensors. So let's do a few of those, okay? So I'm going to go to the first one, and I'm just going to copy this code right here, and I'm going to create a random tensor. So I'm going to go to that link that I gave you guys, right? Click on Playground, and now I'm just going to take that code right there, and I'm going to copy it, right? And I'm just going to go to my Playground, paste it in. And if the demo gods are good to me today, it's going to create a random, there it is, there's my random tensor. So suddenly I prompt engineer all of that. See, I'm prompt engineering my learning. I'm not going to a video course to tell me how to do this or that, but it's learning on demand, right? Here I go. Let's look at the next one.
Hey, Michael, can I share something?
Please do.
As a guy who took several courses online, what you just did probably took me weeks to figure out and how to do, right?
Right.
Yeah.
Right.
What I'm trying to do is I'm trying to make sure that there's impact here. For those that may not know, that this was quite a lot of things to figure out.
Absolutely.
And you had to learn Python, right? So.
Yeah, absolutely. And what I'm saying is, lots of times, I appreciate that, because when we watch these courses, we get the knowledge, and then we have to go build the interface, right? And then we have to work with whatever software, and then the installs. And once you get that, then you're actually building something. It's such a, and you're not really learning yet. And so here immediately you got this on-demand learning, and so you can do this. So I'm just starting to copy some of these and paste them in and run the code right there on the fly. There you go. Thank you for that comment. Whenever I write code now, and if I get to something I don't understand, I used to spend hours in Stack Overflow, right? I don't do that anymore. I just put the code in here and I say, explain this to me. And it explains the code to me. All right. And that's why this is a little different. I'm not telling you to learn the way you used to. I'm telling you to use these tools. All right, I showed you the environment. I showed you all the exercises that you can go through, but I also showed you that this is not your typical input box. This is a code simulator. Just paste code in here and run it. But I also have a playground, so go to the playground and run code there as well. With that said, we looked at some of the exercises that you can do, and I showed you the PyTorch code runner. So it's also another environment where you can paste everything in. All right, next, let's run over to linear regression. Now, I want to build a linear regression system, and there's two parts to building linear regression system here. Is I needed some data, and so I want a random scatter plot. So here's my prompt for the random scatter plot. What is wrong with this prompt? Can anyone tell me? Just read it. Write the Streamlit code for the description below. Plot the results in Streamlit. Add two sliders, one for noise and the other for number of data points. What's wrong with this prompt? I never told it to create a scatter plot.
Oh.
I left out the description below.
So it just did it on its own. It's that smart.
It inferred since I said add two sliders, one for noise and the other for number of data points, it inferred that I wanted a scatter plot. And so, yeah, and so here's your noise level, and here's your number of data points, and here's your scatter plot. And so what you're doing, you're building an MVP, because you need this first before you do linear regression, because you're going to do linear regression on these numbers. And we'll go into the math just a little bit today as well. But that's the first thing. So if you go into your bring up ChatGPT, and this is the thing, a lot of people are behind on what's happening with this technology, right? And they think that it can't do what it can do now. And so they don't realize how rapidly this is moving. So if I put this in here and I run it, there you go. It's going to infer that I want a scatter plot. There you go, scatter plot. Just inferred it. And I left that out. So that's one of the things that the system has gotten very good at queuing. So if I know it's already there and I put the right queued word in there, I'm not going to have to add that. You don't have to tell it something it already knows. And so if you were to take that in, and I don't know what's going to run here, if this is going to work or not. So and I don't know did it do the Streamlit? Let's paste this into our environment and see what happens. Okay, so I don't know if the demo gods are going to be good to me. Okay, guys. So if it doesn't work, don't shoot the messenger. But let's go to our little environment here, paste it in.
Woo! Whoa.
Yeah, so it gave me a scatter plot. Now, the problem with this plot is that you can see it's a sine wave. So I need to go back and re-engineer and say, give me a straight line. But it actually, and that's actually what I did the first time. I actually went and re-engineered it again. So there you go. Yeah, cooking. We're cooking with gas now. All right, with that said, my next thing is I need a regression system. So here was the next prompt I used. I said, using PyTorch, create a good linear regression example and include matplotlib and graphics illustrating the project using a Streamlit interface to show input and output, suggest adjustable parameters. The goal is to implement a simple linear regression model from scratch using PyTorch. Train the model on a small data set and visualize results, okay, and follow scatter plot creation chat history. So I've already created the scatter plot. So I'm going to take this prompt in here. And once again, I hope the demo gods are good to me. So I don't know if they will be, but we'll go ahead and prompt away. But this is how you do it. I mean, I'm just speaking programs into existence. You know, it's just nuts, right? Never in my life did I think you could do something like this. And put this in. And let's run it and see what happens. It says, sure, I can do that. And NN is your neural net. So it's that you can already see it's starting to think correctly. And you can see you've got your 1, 1. So that's your input and out. And then you've got your, let's see, oh, there's your predictions. Let's see if it's got loss and back propagation in here. Let's see if it's doing it right. There's your training your model right here. There's your tensors. Yes, and there's your column tensors. And there's your zero grad. So it's doing back propagation. So it seems like it's doing what it's supposed to do.
Yeah, that would have taken me a decade to write.
You know, this is insane. It really is insane. In my lifetime, never did I think.
I mean, back in the day when I was an engineer and PowerShell first came out, and I'm a GUI guy, right? Not a CLM or CMI,
Right.
And I had to write PowerShell code.
Right.
It was a struggle. I mean, it was just it was absolutely painful. I guess I don't have the logic or the mind for it, but doing something like this.
I've got to really tell you that this gives you wings.
Yeah, that's a good way to put it.
What this requires, and this is something that about a year and a half ago when 3.5 came out and I started working with it, I had that that gut punch, like, wow, I mean, stuff that took me 15 years to learn, it already knows. And I felt like, well, what's my value? And really your value is the ability to connect all this stuff together, to connect the dots, right? And
it's
so
the creativity.
right.
You got to know how everything works together, right?
And I'm saying probably with all your experience, past experience, now you can do things you never thought you could do. And that's why I'm actually taking a different approach. Most people have never seen this approach before. And so it's a real different approach to how we've done this in the past.
Hey, Michael, did you see the question you got there about what does a Streamlit mean?
Oh, thank you for asking that. You see this whole environment that we're working with? This is a Streamlit environment. So it's an environment that we use for Python. And it's different than the other environments that we've had in Python before. If you've worked with Flask or any of the other Python interfaces, they're very difficult to implement. Streamlit just rides right on top of Python, and you can use it to interface with your Python code and create a website. All right, so here's an example of the simple linear regression. And you can come along here and change the noise level, and it will change the points, and it recalculates everything on the fly. And there's your loss function, so that's pretty nice. And you can change your data points. You want less data points or more data points, they'll do that for you. Once again, all this was prompt engineered. I did not write a single line of code here. You can change your epoch. So if you down here, you can see you might not want to run this function because its loss is not that good, right? And you can expand your learning rate, but that makes it go crazy. So you really get to work with some of these parameters. Now, how did I get these parameters? I actually, in the prompt, asked it to suggest these parameters. I did not tell it what parameters to give me. I just said, what parameters do you think I should use? And these are good set parameters right here. So as you work with this more and more, if there's a parameter that you're not getting, then you can come back and reprompt it and say, give me those parameters. Okay. So I just want to show you that it's working fine. And that's our linear regression piece right there. All, once again, completely prompt engineer. Not one line of code did I write. All right. So let's go ahead and talk a little bit about the math. And you saw the loss function there, so that's nice. Just a little bit about the math if you're not familiar with this type of mathematics. We have an equation here, and this pretty much is the equation for a straight line. But we're going to basically want to use linear regression on this line. So we're going to basically let W be our weight and B be our bias. And what you're going to use is you have a costing function here. And and that's pretty much is y present minus y predicted squared. And that's your mean squared error. And then what you're going to do is take the derivative of it, which is Jacobian. And that it's just like, think of it like a parabola. If you guys ever did like calculus, when you took the derivative of the function, the minimum is when you equal to 0. And what you're doing in gradient descent, you're just looking for the minimum, right? And so you can have these multidimensional functions, and in this multidimensional space, you're looking for minimums. And that's what gradient descent is actually doing for you. And so that's when you do that and you minimize this cost function, then it turns out that this is trained to give you the optimal answer. So the other thing is a little brief here on learning rate. If your learning rate is too small, it takes a long time to get there and it may never get there. And if it's too big, it just jumps all over the place. It's erratic. So it's kind of an art to determine what that learning rate should be. We did talk a little bit about, asking, what does this code mean? And so if you get code and you don't know what it means, well, that's great, because just take that code, write into ChatGPT and say, please explain it to me. And that's one of the things I'm saying, guys, with these systems, is that you no longer have to go to a textbook, no longer have to go to a video course. You can go right in this system and say, please explain this code. And it will go through there and it will explain every line of code. If there's a certain function, so you may not like all the explanation, maybe there wasn't enough explanation, maybe there's a certain function that you want to know more about. So you can stop that and say, what does this do? And just copy it and go right in here and go, what does this do? You put that in. I use 3 dashes sometimes to separate. I use colons, I use brackets, and it's going to go in there and give you a nice explanation of everything that can do. Once you've kind of done this, you're pulling knowledge in. You're kind of digging a hole to put stuff in. And so once you do this, then go to the video course, and watch the video course, and then work with the code simulation or build your own code simulator and start pasting code in there and playing around. So what I'm telling you to do is a different way that we've been able to learn before, because we haven't been able to just speak things into existence. Now that you have this type of technology, you can just speak it into existence. It's like just nuts. Wouldn't you agree, old Joe? Nuts. So anyway, that was the expression. Next thing you want to do is your logistic regression. And so here's the prompt for logistic regression. And I actually have 2 prompts here. The first prompt, I said, using PyTorch, build and train a logistic regression model for binary classification, predicting whether a student passes or fails on study hours. And 2, put on it a streamlit interface, provide all appropriate inputs and outputs, use matplotlib for plotting. So the first one will build it out without the interface. You'll just build some code. So I'm actually like building a minimal viable product. Then I change it a little bit. And so that's why I'm really successful in prompt engineering. I don't try to do everything at once. I think about, what is it going to sit on? What's the platform? And so you build that platform, and then you just start adding to it and adding to it, and adding to it. At some point, something doesn't work, you reverse and you start again. But as you think through this and begin to work with these different prompts, it'll start to become natural. So let's run this prompt and let's try this first prompt. Let's see if we can build. And this is the famous, and you can see it says right here, you got the famous predicting whether a student passes or fails on study hours. That's the famous example. And here they do 4, 6, and 9. So we'll go to our chat GPT. All right, now sometimes if you're prompting something else, you maybe want to clear or refresh your screen, because it'll take that into account as well, as far as if it's keeping history. If you're doing a minimal viable product, you want to continue to prompt in that screen because it's keeping context of what you've done before. So we'll go ahead and put this first prompt in and cross our fingers and see if the demo gods are good to us today. And so what it's going to do now is going through, it's going to build that logistic analysis for me, but it's not going to put an interface on it. Okay. Someone asked, what's a streamlit interface? And that's a good question. It's actually what you're going to use in a sense to interact with it as a person. That's absolutely right. Hi, Gray. You can actually tell it to bring it down, to explain it at a younger age. Now, I actually use this. And let me explain how I use this. There are certain concepts that are very complex, and I want to build a course around them, and you don't want to have those complex questions appear in the outline. So I have on occasion when explain this to me or create this course or create this outline for 11-year-old. And you would be surprised what 11-year-olds are expected to know. But I've gotten some good results from that. And that is actually a very powerful technique. Another powerful technique is creating simulated data. And I do that as well, a lot as well. But let's take a look and see what we got here. It's saying that it created, let's see. First thing it said it did is it imported the necessary libraries. And you can see you're going to scikit-learn here on this one. It generated synthetic data. And that's something that's extremely powerful. I want to just stop on that one. What you're going to find out, lots of guys, is this is one of the most powerful features that I love in dealing with these generative AI is the ability to create synthetic data. If you're working with PII data, and you know what I'm talking about, personal identified information data, you don't want that to get out into the public. And so you really typically can't work with PI data in sandbox or in even development. But what you can do is create synthetic data that looks like it. And once you create all that synthetic data, you can build your programs. And as long as the synthetic data mirrors or is very much like the PI data, it should work fine. And then once you build those programs, once you push them into production, you should test them there, right? Ability to create synthetic data is very powerful. And in this particular example, without me asking, it knew it was going to create synthetic data to do this training. Then it's going to do your data processing. It's going to define your logistic regression model. It's going to set up your loss function optimizers. So everything that's all great PyTorch stuff. And it's going to train your model. And so that's actually pretty nice. And then it's going to evaluate the model and it's going to visualize the decision boundary, which is fine. It's creating your plots. But what I want to do is I want to go ahead and go put the next one on there, put the Streamlit interface on there, and put the matplotlib on there. Now, let me tell you what happens a lot. If you guys are doing a lot of generative AI, you're probably running into something called a Jupyter Notebook. Okay.
Oh, yeah.
Everyone's using Jupyter Notebooks. The problem with Jupyter Notebooks, you can't interact with it like it's an application. You need to be able to build an application. So that's why I'll use Streamlit. So I'll take a Jupyter Notebook. I'll copy the entire thing in. Why am I copying the whole thing in, even with the comments? Why do I leave the comments in? Anybody have an idea?
Makes it maintainable.
It's not necessarily.
And it helps the prompter.
There you go. Absolutely. It's queuing. It's queuing the prompter. Matter of fact, I'm going to tell you, that's really good. You hit it. You nailed it. You get an A+ for that.
Thank you.
Because what happens is many times, yeah, yay, you get an A+ for that. What I found out sometimes when I put all that comments in there, the code I get out is better than the Jupyter Notebook because the guy who put the comments in there expected more than it was actually coming from the Jupyter Notebook. But I'll throw it in there. I'll say, give me a stream and interface, give me interface, give me inputs and outputs, and now it's an application. I can interact with it.
Yeah, just a quick one, because you mentioned Stack Overflow earlier, and a lot of my comments in Jupyter Notebook are the URL for where I got the code I'm using, at least the template for it. If that is included when you paste the code, does it take the actual Stack Overflow answer into context, or does it just ignore the URLs?
And the answer to that question right today is no. It's not going to, and it's not going to use those links that I know of. But next year, will it? Most likely, yes. So, okay. Yeah. Thanks for that question. Good question. Any other questions on that along those lines? So what I'm going to do now is I'm going to go next to go get the rest of this prompt. I want to put a Streamlit interface on this thing so I can interact with it. And like I said, the same thing with Jupyter Notebook. You got a Jupyter Notebook, just paste it in ChatGPT and say, put a Streamlit interface on it, give me the inputs and outputs, and it'll do it for you. And so let's go back to my chat system.
Imagine the thing goes for the Google Colabs and all that stuff.
Absolutely. Yeah. And so I'm going to say, put a Streamlit interface on it, and it's just going to, and I'm going to say, suggest the inputs and outputs. And it's going to go through there and it's going to start doing that. Oh, sure, I can do that. So, ChatGPT 4.0 is really great with Python, and it's really good with Streamlit. So I'm tickled pink, especially since I'm doing a lot of experiments in this area, and I'm playing around with. And this is good for hackathon type stuff. It's also good for experimentation, for rapid prototyping, and everything else. So a lot of people are using Streamlit, using Hugging Face, all these different technologies to this. Yeah. So that did that, and we'll go take a look at that in my Hugging Face example. So if you got Hugging Face and you go to that PyTorch that right there, you can go to logistic analysis, and you can see there you go. There's your loss curve, and there's your prediction. And so right now, with the number of epochs that I have, I did 1,000 epochs with a learning rate of 0.01, and then the test study hours that is trying 4, 6, and 10. All right. With that said, you can see how that runs, and let's run 5,000 epochs and see if the curve gets better. And the reason the curve's not that good is because it's synthetic data, and we didn't put a whole lot of you know, a whole lot into that synthetic data. We didn't tell it how to engineer it. So it just, created synthetic data for us. I don't think that was that good. Here I had to do a lot, 5,000 epochs to get it down to a point or a 20% loss, which there you go. And what it's saying on this one is if you study for 4 hours, a probability of passing is 41%. If you study for 6 hours, you got an 80% chance of passing. If you study for 9 hours, you're probably definitely going to pass. And so I probably choose the 6 hours, right? If all I want to do is pass.
I have a question.
Yeah, go ahead.
You mentioned that basically the curve wasn't that good because you put you didn't tell it how to do the describe the data enough.
Right. The synthetic data, if you go and look at the creation of synthetic data, it's somewhat random. And so if I'd done a better job of creating synthetic data, I think I would have gotten better results with
Yeah, but sorry, I'm not trying to interrupt, but that's not my question. This is my question.
Yeah.
Doesn't that kind of simulate the real world experience for data science, where you get some bad data, you really got to make it good, and then you put it into the
bad data in, bad results out.
Garbage in, garbage out, right?
Thank you. 80% of course, data analytics, right? Data science is cleaning data. So this brings up a really good point. Let me just make it here.
Yeah, but let me just bring my last point in here. That's why I was asking about it. I thought that was kind of a good way of leading you into the right way of building it. I thought. Because
Absolutely.
I was kind of surprised when you said when you were talking about that.
What I would do here is I would reprompt it in the sense as you build the data. Here's some requirements. Or I might ask it, what would be some good requirements to get a better data, right? Get a better loss.
Yeah.
I could go ask it that and it would give me that. So that's, just the opposite.
You know what I would ask it?
What?
I would ask it, what are some ways to build some real world data such that you get all the normal mistakes and stuff like that into it?
That's absolutely. That's a really, really good point. Thank you so much. And that's what's so crazy about this. See, what has happened is it's captured human reasoning. So if you get to the point where we start, let's start reasoning with it. And what is your reasoning? Why do you come up with these ideas? It will do that for you. And so you're thinking that way very well. You're already using that human reasoning, thinking about how to reason with this.
Well, I'm just listening to you and just,
you're doing
that's basically it.
Excellent. So let me see. I had one more point about this. And what I was going to say is that whole data piece, that's about 80% of it. So here's the thing. We were so surprised when we started coding with these systems that the code was so good. Now it's even better. But when we first started, we expect crap, right? And what it is, people think they train on the whole internet. That's not what happens. They have what we call a mechanical Turk. There's people in the loop here. And so you get all this code and you have these professional coders and they say, that's good code, that's bad code, that's good code, that's bad code. They only train on the good code. That's why when we're coding, all of a sudden, I didn't ever think about it. I could do it that way. Or you can put bad code in there and it'll improve it. So the fact that you have the human in the loop is what, and getting good data and training on good data, that's why you're getting such good results here. Today's lesson is not on vector databases, but my last presentation has some vector database stuff in it. So make sure you check that out. Are you on my LinkedIn? I think you are, right? Are you on LinkedIn?
I'm not sure.
Well, join my LinkedIn. I got tons of stuff on there. So you want to make sure. Let me go ahead and put my LinkedIn here.
Yeah, I guess a good example that I found for validating how good any of these AIs are doing code, and I can't remember who it is, but there's a guy who has Python code to make a snake game, right? Remember the snake game on your old Nokia phone?
This is Matt Berman. Matt Berman is constantly doing these comparisons. Yeah.
Yeah, he'll put that code in there and see if it does it, how well it does it, or he doesn't put the code in, he says to do it, and then he says how well does it do it, and that's like a Turing test almost, right?
Right, and I think that ChatGPT 4 has done really well. 4.0 has done really well, and so it's actually able to solve problems that we haven't been able to solve before. So I'm actually, I'm gonna bring up my slide deck. So we have a few more minutes here, and I want to wrap it all up. Okay, guys. So we're almost there, and there you go.
Well,
you should be able to see.
There it is. Yeah, there you go.
All right, so this is the LinkedIn version, which is probably good. So they're all on LinkedIn. So if you go on here and you can scroll down, not all sized right, but I want to make sure I can wrap this up, okay? So basically, we went through the MVP and how to create the linear regression. Then we got on to the math of it all. And we talked about learning rate. And then we talked about explaining the code. And then the logistic regression, we got into that. And just some of the math behind logistic regression. We're kind of, once again, working with that straight line idea, but we're putting it into a sigmoid function. And the reason we're doing that is because that gives us a probability of 0 or 1. And once we have that, then we can do something like we call a cross entropy optimization. And we're doing the same type of gradient descent. And we're looking for the minimum of the curve. And that's how we are able to actually make that code work. And with that said, I wanted to make one more comment. I really only had one more slide, and that's using Hugging Face for minimal viable products. And so what I do on Hugging Face, and I'll bring that up real quick, is when I create code, I don't like to erase it, all right? And so what Hugging Face allows you to do, it allows you to, in a sense, to create an application. That's your initial Python, and that's my introduction to the course. But then within that, you can create, and by the way, this code is all available to you guys. You can just go to it and see how it's built. And you go to pages, and then you can put all your stuff that you're building in there. If you put in 1_2_, that lines it up for you. And so what you can do is put a program in there, do some work on it through prompt engineering, and then put the next version of it next. And do some prompt engineering, and then put the next version of it next, and do some prompt engineering. So it allows you to build up code. And
show me how you run that from. Can you run that from right there inside that page?
I don't run inside this page. What you do is you just hit the app, and then it lines everything up here on the side.
Oh, okay, okay.
Which is really nice because you can go through here and you can see how I built the minimal viable product. And the next thing I built was a linear regression. And the next thing I built was a logistic regression. And then here's my PyTorch playground. And so you'll see, and I'm going to build the rest of this course out over the weekend. So it'll all be up there. So you guys have this link. All you have to do, guys, is go to this link and just go right to files, and all the code's there for you. Okay. And that brings us right to the end. Thank you for coming. So I'm here to talk a little bit. If you guys want to have any discussion or anything, I can hang out for a few more minutes. But thank you so much. I'll get this video done and get it up on the web.